brought over the constraints from the previous page over here. So we're going to be talking about the phase 1 of two-phase method. And so what we've done is we've added a artificial variable x6, and we now want to minimize x6, subject to all these being non-negative. Now, if you recall, let's find out what the basic variables are going to be and what the non-basic are going to be. Well, we're going to have x3, x4, and x6 be the basic variables, and we're going to have x1, x2, and x5 be the non-basic variables. And so, as usual, we have the question, which of the x1, x2, and x5 should enter the basis? Well, the first thing that we need to do is we need to express the basic variables in terms of the non-basic variables. We'll do that right away. So we have x3 is equal to 16 minus x1 minus 3x2. And we have x4 is equal to 7. Missed an x1 here in copying over. x4 is equal to 7 minus x1 minus x4 minus x2. And we have that x6 is basic. x6 is equal to 2 minus x1 plus 3x2 plus x5. Okay, that's what we have. And we have z is equal to x6. We are going to have to say, since we want to express this also in terms of non-basic variables, this is going to be equal to, so that we can also say that z is equal to 2 minus x1 plus 3x2 plus x5. So the question now is which variable should enter the basis. And we're going to do the same thing. We have that we're trying to minimize z, then x1 is the first variable that will enter. So we'll have x1 enter. Okay. Well, x1 enters. Then we go here. This area here is the area that we have for our departing variable. If x1 enters, then as x1 goes up, then x3 goes down, and until x1 is equal to 16, that's as high as it can go. And in the second constraint, as x1 goes up, x4 comes down, and it can go up to 7. And in the third constraint, as x1 goes up, then x6 comes down, and until x1 is equal to 2. So clearly, this last constraint is the one that is limiting on x1, and therefore that means that x6 departs. And so we're going to now just solve this. So this is what I meant when I said earlier that we're going to use linear programming to solve this problem. The problem of finding an initial corner point of this multidimensional feasible set, where we don't know even one point on the feasible set, we haven't got a clue, can itself, we know the equations of the feasible set, can itself be solved by linear programming by first minimizing this artificial variable. And this artificial variable is a measure of how far we are from the feasible set. One practice which might be useful is right on the same page, after you've identified the entering and departing variable, that we right away also record the new b. So x6 departs, so we're going to have x3, x4, x1, and then the non-basic variables are going to be x6, x2, x5. So if we know that, then we know that x3, x4, and x1 are the basic variables. And so we can now proceed. I've done a little bit of homework by putting this here. And now we need to again express the basic variables x3, x4, x1. x6 is departing, so this is going to be the pivotal row. So x1 comes in, x6 goes out. So where I'm going to have x1 equal to 2 plus 3x2 plus x5 minus x6. And we have to then proceed with substituting x1 both in the x3 and the x4 and in the z equation. So let's do that right now. I know it's a little So x3 is equal to 16 minus 2 minus 3x2 minus x5 plus x6 and minus 3x2. So x3 therefore is equal to 14 minus 6x2 minus x5 plus x6. And then that replaces this equation here. And similar with x4 is equal to 7 minus 2 minus 3x2 minus x5 plus x6 minus x2. Then puts me as x4 equals to 5 minus 4x2 minus x5 minus plus x6. And that takes care of that equation. So I'm left with x3, x4, x1. So I'm doing good. And the last one is the z. Is 2 minus x1 minus 2 and then plus 3x2 plus x5, and then this is equal to 0, and 3x2, that's 6x2, sorry, 2 minus 2, and then minus 3x2 plus 3x2, that's 0. Minus x5 plus x5 is 0. And so I am left with x6. Well, x6 is non-basic, so this is equal to 0. So basically I have eliminated x6. And what I have is I have a basis of, there's no entering variable. I stop. There's nothing to change at this point. I'm trying to minimize x6, and so it has reached a level of 0 because it's non-basic. So I'm done. There's nothing to check anymore. So I'm at the end of the phase 1 of the phase 2 method.